For question number 7, we want to look at this graph and find the Laplace transform. So this one is similar to the piecewise defined function that we just did. But I'm going to work this one with unit step functions instead. We could work this with the definition for the Laplace transform if we wanted to, but I'll do this with unit step functions. So I'm going to rewrite that piecewise defined function, the graph, in terms of a piecewise defined function. So we have one line, I'll call it y1, that's defined from t equals 0 to t equals 1. And then after that, this is y2. We'll say y2 is 0 when t is greater than or equal to 1. So for y1 is a straight line, and so it obeys mx plus b. In this case, our variable is t, not x. But m is our slope. Notice from this point at 0, 1, we're going down 1, that's a minus 1, and we're going to the right 1. So our slope is -1 over positive 1, or just -1. And then b is our y-intercept. So b is 1. So y1, the equation for y1 is negative t plus 1. So in terms of unit step functions, you can write this as, start with your first definition, negative t plus 1, and that's true for all time. And then starting when time is equal to 1, we want this to cancel out. So we're going to subtract off, put -1 times negative t plus 1, and multiply that by our unit step function that takes effect when t is equal to 1. So at t equals 1 and beyond, we're going to have negative t plus 1, and then this is going to be a positive t minus 1. And everything will cancel out. The negative t and positive t cancel. Positive 1, negative 1 cancels. So here's our function. And then to find the Laplace of f of t, we can do this term by term if we want to. We have, well, let me do it not term by term, but let me do Laplace of negative t plus 1. That's just using regular Laplace transforms. And then on the second part, we have the Laplace of t minus 1 times our unit step function with the same shift. So what's important is that we do have this same shift, that the t shifts to t minus 1. So the first Laplace transform just comes out, use your tables, and the Laplace of t is 1 over s squared. So that's -1 over s squared. The Laplace of 1 is 1 over s. And then for the second part, we're going to use that second shifting theorem to pull out that unit step function. That's going to come out as e to the negative s. And then we're going to be left with the Laplace of t. Take away the shift from t minus 1, and you're left with t. And so now I can finish up. I get -1 over s squared plus 1 over s plus e to the negative s times the Laplace of t, we just did that up here, is 1 over s squared. So this is the answer. You might see, if this is a multiple choice question, you might see that these s squared terms are combined. And if you combine those s squares, you have, I'll put the positive term first, e to the negative s minus 1, and then plus 1 over s. So that's a good answer. And it's even possible that you combine all of this into one fraction, which would be pretty easy to do. Just take that second fraction, multiply by s over s, and you'll get e to the negative s minus 1 plus s over s squared. So 3 of those answers are really good answers. And that's question 7.